This video is intended to help students navigate some tricky integration by parts calculus questions. The key indication that we're working with an integration by parts question is that we have an integral with a product inside of it. The items that make up this product are known as u and dv when dealing with an integration by parts question, and they are used to find the final workings out of the problem. So in this case, with just the example formula, you can see that we use u to find du using the derivative, and given dv, we can find v by simply integrating. Finally then, to get our final formula for integration by parts, we simply map out u, du, dv, and v going across first from u to v, and then subtracting the integral of v to du. And now that we know how to make the formula for integration by parts, let's go ahead and start working out some problems. First up, we've got the integral of arctan 2x, which on the face of it may not be immediately identifiable as an integration by parts question, but you'll have a tough time figuring it out if you don't recognize that it's something you can do by IBP, integration by parts. It's important to recognize that questions like this, they're not simply just arctan 2x, rather it can be used as 1 times arctan 2x. And in that case, now you've got a product of 1 and arctan 2x, and that you can apply the rules of integration by parts to find a solution. And so to start working this out, we need to make our map of u, du, dv, and v. So we'll start by identifying which quantities we'd like to use for which circumstance. And in this particular question, I think that I'm going to use arctan 2x as my u. So we'll let u equal arctan 2x, and then we'll put down a little spot for du there, and we'll say that dv in this case is just 1. And of course, with respect to x, we know that the integral of 1 is just x. And now we just need to solve for the derivative of arctan 2x to find our du. And the arctan of 2x, the derivative of that, is 2 over 1 plus 4x squared. And so now that we've got those worked out, we can go ahead and start building our integration by parts skeleton. We'll start just by going across u, v, so we'll go ahead and implement that, and we'll say x, that's our v, times arctan 2x, our u, minus the integral of v du, which in this case we have a 2 as our top numerator there in du, and we'll just go ahead and kick that out front, and we'll pop the x in its place up top over 1 plus 4x squared dx. So this is our official, skeleton of the integration by parts problem that we've worked out from the initial integral. And the interesting thing about this question, and what makes it a bit tricky, is that usually when you do an integration by parts, your result looks a little bit more straightforward than the initial integral that you had. But in this case, the result that we've got, it looks a lot more complex than the initial integral we were given. It's important to recognize that with this particular question, the next step is to solve the given integral. And to solve that, it's as simple as just doing a u sub. And I think to do this u sub, what we'll do is we'll set u equal to 1 plus 4x squared, and du in this case will just be 8x. And because we have an x up top here, we can go ahead and divide the 8 there, and that will allow us to end up with x dx for our du. And so what this ends up looking like is still x arctan 2x on the left, minus now, we've got 2 over 8, which is just 1/4, so we'll simplify that now, times the integral, we've got x dx, x dx, so that's just your du. So what we'll have is 1 over u du, and this again, of course, will simplify once more to x arctan 2x, and then we'll do minus 1/4, the integral of 1 over u is just ln absolute value of u, plus c. And in this case, u was 1 plus 4x squared, so we can go ahead and plug that back in. And we'll get x arctan 2x minus 1/4 ln absolute value of 1 plus 4x squared plus c. And of course, it's important to note that in a question like this, we end up with absolute values around our ln item because we integrated. But in this particular instance, because x here is squared and there's no negatives in this item, this number can never be negative, and therefore the absolute values are redundant, and many people will judge you for having them. So just go ahead and put those in parentheses. Some professors may not care so much about that, but it's always kind of best to just go ahead and do that, because a lot of professors will take points off for not simplifying those absolute values when they're redundant. And so now, moving on to our second integration by parts question, we've got the integral of t cubed ln t dt from 1 to 3. Now, this one is important to note that we're dealing with a natural logarithm here. And whenever you see an ln pop into the product of the integration by parts, you always want to let that be u. So in this case, we'll say u equals ln t. And the reason for that is because we can easily differentiate that to get du, which is just 1 over t. If we were to set that for dv, we'd have a really tough time integrating that to just solve for v, and then it really just wouldn't simplify the equation whatsoever. So in this case, we'll let dv equal t cubed, and then of course v will be t to the 4th over 4. And so now that we've mapped that out, we're ready to build the skeleton of our formula. And so we'll go across from u to v, and then we'll go back down with the integral of v du. So u to v, we're going to start with 1 over 4 t4 ln t. We just brought this 4 here out front and made it a 1/4. And then we'll subtract the integral from 1 to 3. Again, with that 4 there, what we're going to do is we're going to pop that out front here. So 1/4. t4 over t is simply t cubed, and that's with respect to t. Now, this is an important part of integration by parts. Whenever you separate the factors here and you have an integral with limits, like in this case we have 1 to 3, we also need to go ahead and add those here, because we're going to have to iterate those limits across this entire thing as if we were integrating it. So we'll have to subtract those, and I'll show you that in a moment. What we can do is rewrite this and we'll simplify it. We'll say 1/4 t4 ln t from 1 to 3, and then we'll subtract 1/4. And this is convenient. The integral of t cubed you've already done here, and that is just t4 over 4. So we'll go ahead and throw that in here, t to the 4 over 4, and that again is from 1 to 3. And so now we just need to solve. So what we've got is 1/4, and we'll go ahead and say 3 to the 4th ln 3 minus 1/4. Well, and this is where you can go ahead and rewrite the whole thing, or you can kind of look ahead at the problem. And it's kind of convenient to look ahead, because then you can cut out some unnecessary stuff. Here, we've got an ln t, and we'll be plugging in this 1 into the t. And what that means is ln of 1 is just 0. So whatever this subtraction would end up being, it would just be 0. So it's irrelevant. So we'll go ahead and skip writing that this time, and we'll just move on to the remainder of it. Minus 1/4 times t to the 4 is 3/4 over 4 minus 1 over 4. Now, 3 to the 4th power is 81. So what we've got here is 1/4 times 81 ln 3 minus 1/4 times 81 over 4 minus 1 over 4. And we can go ahead and simplify that as just 80 over 4. And then we can go ahead and simplify that again as 80 over 16. And that once again simplifies actually to 5. So what this really is 1/4 times 81, which I guess we can go ahead and solve that. We'll just say 81 over 4 times ln of 3 minus 5. And that is the solution to our integration by parts question. That's all the time I've got for today. I hope that you found this helpful. If you did, please consider leaving a like. And if you have any questions, or if you want me to cover any other topics in calculus or physics or something like that, please let me know in the comments below.